In this video, we're going to talk about normal distribution. Now, before we even talk about what a normal distribution looks like, let's do an experiment. Suppose that you have two dice and you're rolling the dice and taking the sum of the two dice. You're adding the two numbers that you see, and you record how many times you get each of the numbers. First, I want you to think these are all the possible numbers that you could be getting as a sum, so 2 all the way to 12. Think to yourself, which one do you think is the most common combination to get and why? So which one do you think 2, 3 out of all of the 11 or 12 is the most common one and why? You'll notice that on the screen right now are the probabilities of getting each of these sum of numbers. And let's try and roll this dice 100 times and see what we get. The blue bars indicate what we're getting when we're rolling our dice. Let's see what happens after we've rolled 100 times. We notice that seems to be a stronger concentration in the middle than there are to the side. Let's see what happens when we do it 1,000 times. Does this concentration change? What is happening over time? Now, remember, this is experimental data, right? So experimental data doesn't follow the theoretical probability exactly. But we see that the more trials we have, so 1,000 compared to 100, the more trials we have, the closer we are to the expected probabilities. And that is that 7 is our most common sum because we have the most combinations possible to make 7. And what you notice is when we graph all of this, it kind of creates what we call a bell shape. It's higher in the middle and it's lower at the bottom. This is what we call a normal distribution. And many phenomena in our world are normally distributed. So here are just a few examples. If you take the height of all 16-year-olds, you'll notice that they're normally distributed, where the majority of them are in a middle height, and then we have not a lot of them who are a lot shorter and a lot taller. Length of adult sharks, volume of liquid in a soft drink can, the life expectancy of batteries. So all of these are examples that we're going to be looking which are normally distributed. Let's talk about the property of this curve first. So the characteristics of this curve, like I said, we're looking at what commonly is called a bell curve, where most of our data is concentrated in the middle, and then we have less and less data moving away from the middle. What's important to know is that this curve is symmetrical, so meaning the middle line is the exact halfway mark. So the middle line actually represents our median, halfway mark, our mean, the average, and our mode. So that's the most important thing to realize is for a normal distribution, this middle line doesn't always have to be 0. This number line is going to be changing. This middle line is always going to be mean, median, and mode of our data. Next, we're looking at our characteristic where if you look at the area under the curve, so under this function, it's going to be equal to 1 or 100%. So under this curve, we're going to encompass all of the probability possible. The next parameter that's super important is the standard deviation. Now, we're going to talk about this empirical rule, which is the 68, 95, and 99.7 rule. And we're going to be using the standard deviation in order to talk about it. When we're moving away from the mean, we're going to talk about moving away one standard deviation. So in this example that you see here, the standard deviation itself is 1. So when we're moving away one standard deviation on both sides of the mean, well, in this range, we say that there's going to be 98% of all of our data is going to be one standard deviation away from the mean. So that's kind of a cool idea. When we move 2 standard deviations away from the mean, well, we're going to say that 95% of all of our data is going to be 2 standard deviations from the mean. And then the last one is moving 3 standard deviations from the mean. Oh, sorry about that. And that's going to be 99.7% of all of our data. So we'll notice that when we're 3 standard deviations away from the mean, anything outside of this is very unlikely to happen, right? We only have 0.3% chance combined of happening on both sides. So the standard deviation is going to be a really important tool for us to compare our data. And then the mean is going to be a tool to centralize our data in the middle. Now let's talk about notation. So notation is going to be really important in the IB. They're expecting you to know how to do it. So the notation is we have a variable x, which is distributed. So this sign is distributed. And it's distributed using a normal distribution. So the n stands for normal distribution. Remember, we had the same notation for binomial distribution, right? So binomial distribution had capital B here instead. And then in brackets, we're going to have our 2 parameters. So our first parameter, you'll notice this symbol. This is your mean, right? So this is your mean. And then it's separated by a comma. And then the second symbol, we need to be careful about this. The second symbol is the variance. So this is the variance of our curve. Notice that the way that we describe variance is the standard deviation squared. So very important that we take into consideration that this second number is the variance and not just the standard deviation. One thing that we're going to want to make sure that we know is that when we're taking into consideration a normal distribution, our data is what we call continuous. It doesn't have to be discrete data, which was the case for binomial distribution. So now we're looking at at continuous data, data that could easily be grouped into categories, or data that can be very precise, like your height, where you could be 172 centimeters. You don't need to be exactly 170 or 175. For your exam tip, so make sure that we know that this is our variance. Even though we're not using the variance, we're going to be using the standard deviation. We use this number in order to find the standard deviation. So if we look at the example we have here, 9 corresponds to our variance. So if we're looking for the standard deviation, then we're square rooting this. Now, the most important thing for you to know is what 2 types of questions are commonly asked in the IB. And we're going to go through the 2 different types of questions in this video, and we're going to practice with them. The first type of question is when you're looking for a probability. And when you're looking for a probability, you can have a question like, what is the probability of getting a score higher than 54%? So for this type of question, you're looking for a probability, and probably earlier in the question, they gave you the information about your standard deviation and your mean. So you're looking for a probability. In your calculator, you're going to be doing what's called NormalCDF, and I'll show you what that looks like in a moment. The second type of question is when you're given the probability, but you're looking for a specific X value. For example, you're told 20% scored less than a certain value. Find this value. In your calculators, you're going to be using what's called inverse normal. So these are the most important calculator tools. In the corner here, you'll notice that you will never use what's called normal PDF. Now, thinking back and when we were doing binomial distribution, we were using CDF and PDF. For normal distribution, we're only using CDF or inverse normal. So now it's time to take out your calculator, and we're going to look how we can use our calculators. So for your calculator, we're going to be looking for distribution. So the way that we find distribution, we're going to go second function, click on vars. So you see on the top it's written distribution. So we're going to click on here. You're going to notice that we have some options here at the start. So normal, PDF, CDF, and inverse normal. We're never going to use the first one. We're always going to use either the second one or the third one. Let's practice. So our first example for today, the height The height of a grade 11 class is normally distributed and has mean of 170 centimeters and a standard deviation of 2.5. Find the probability that a student chosen at random is taller than 175 centimeters. Okay, the first thing I like to do with these types of questions is I always draw a little bell curve to understand what is happening here. My bell curve is always on a straight line, a number line. If my mean is 170, that means that 170 is in the middle. My first question is asking me, find the probability that somebody is taller than 175. So 175, I'm on this side. My bell curve is not to scale, of course. So 175, and I'm looking for taller. So I'm looking for the probability that we are in this section here. Okay, so when we're looking for probability, what you're going to do in your calculator is you're going to go and ask your calculator to do normal CDF. You're going to use the second option. It's going to ask you your lower bound, your upper bound, your mean, and your standard deviation. What we want is we're looking for 175 to infinity. Your calculator automatically puts a determined lower bound if you want to use that. But in our case, the lower bound is 175. So let me change that to 175. The upper bound, well, there's no end to our normal distribution curve, right? This continues until infinity, technically. So our upper bound is going to be a really, really, really big number. So I like to use a big number like, for example, 10 to the power of 99. And make sure you just close this bracket here. So 10 to the power of 99 is a huge number. And then I'm going to input my mean, which is 170, and my standard deviation, which is 2.5. And we're going to go into paste, and then this is our computer notation for it, and we're going to click enter. So we get that the probability of having a student bigger than 170 is 0.0228 if we round, so that means 2.28%. That's our answer for A. Now for B, what is the probability that we're smaller than 160? Okay, so 160, we're even further away from the mean, 160, and smaller than. So I'm looking for this probability here. Already I'm thinking, okay, I'm expecting this number to be super small. Why? Because my standard deviation is 2.5. So 2.5 away from the mean, another 2.5 away from the mean. This brings me to 165. So I'm technically 4 away from the mean. That's huge. So I'm expecting to have a very, very small number in here. Let's see if that's the case. In our calculator, we're going to go second function var. We're looking for a probability, so the second option. My lower bound in this case is a very, very small number. So a very small number, I like to put negative. So let's use the negative sign. Again, 10 to the power of 99. So that's a very small negative number. Our upper bound is going to be 160. And then we have the same mean and the same variance, and we're going to click paste on here. And in fact, we get a very, very, very small number, right? So 3.17 times 10 to the negative 5. That's very, very small. So if we take this number, we have 3.17 times 10 to the negative 5. That's not a plus, but a times. Sorry about that. Cool. And this is a decimal value, right? So the decimal value, if we remember, we're going to go 1, 2, 3, 4, 5, and that's where the decimal goes. So we have 0.1234 zeros, 317. So either you can leave your answers as a decimal form, which is fine, or you can leave it as a percentage form. Our next example is the mean of a test is 85%. The standard deviation is 3. Find the probability of scoring between 82 and 91. Again, I always start with drawing my bell curve to understand what is happening here. So your bell curve does not need to be nice, it's not an art class. And then my mean, which is in the middle, is 85%. I'm looking for the probability of scoring between 82, which is one standard deviation away, right? So 85 minus 3 is 82, and 91. So I'm looking for this probability here. Okay, well now in this situation, we have our lower bound and our upper bound. They're specific numbers. So we're gonna go back into our calculators, second function vars. We're doing normal CDF. My lower bound is 82. My upper bound is 91. I have a mean of 85, and I have a standard deviation of 3. And I'm going to click enter to this. So the probability of this happening is 0.819 if we round to 3 significant figures. So you can either leave it as a decimal, or you can put it as a percentage, which is 81.9%.